Now, reflective and rotational symmetry. Now, symmetry is for reflective, so it kind of sounds like reflection. It is a mirror line that makes one side, one half of the image be the reflection of the other half. So, for example, looking at here, identify the true statement or statements, it could be more than one, regarding reflective symmetry. Like, is there a line? It's a mirror line that I can draw it like right in the middle that it will make one half of the image be like the reflection of the other. So first I asked, looking at my choices, there is reflective symmetry over the x-axis. So what I mean is, if I was to do the x-axis, and if I was to reflect one image over the mirror line, if I was to reflect it, it will look something like this. Remember reflection, you count the spaces and move it to the other side. What reflective symmetry means, if I was to reflect it, I finish with the initial image. Not the case, right? If I was to reflect this blue with red, I don't finish with the initial image, right? I moved it. So nope, it's not that. I'm gonna say it's not that. It's not symmetry over the x-axis. Does this have symmetry over the y-axis? So I have this y-axis here, and if I move this half, I've landed right here. Hmm. And if I flip the other half, if I was to flip everything, I finish with that. Is it is the reflection the initial image as well? Yes. Yes, in this case, it does have reflection over the y-axis. Good. So I'm going to choose the y-axis. Does it have reflection over the line y equals negative x? So this line. No, right? It kind of finished with something like that. No, it doesn't have reflection of the y equals x. None of the above. Not true, because I had one of the choices. So there. I identified the true statement. Now for number 30, find the number of unique lines of symmetry. Okay. What I do for symmetry, I look at my sides and I cut them in half, like right in the middle. And I cross it perpendicularly. We saw perpendicular at the beginning with constructions. Now perpendicular is about in the middle, so I'm gonna say about here, because I'm looking at one of my segments. The segment I'm looking at is this one, and I cut it perpendicular in the middle. Would one half be the reflection of the other half? Yes. Now sideways, sideways, let me come up with another rule right here. Boom. Would one half be the reflection of the other half? Yes. Now, another thing that I tend to do is in the angles. Let me go with blue here. Will one half be the reflection of the other half? I would say yes if this was a square. But because it's a rectangle, I will finish with somewhere about here. So no, not on the corners. All right. How many unique lines of symmetry did we find? In this case, I'm gonna say two. So gotta check the sides, cut them in the half perpendicularly, cut the angles as well to see if it helps. Notice how I went from one corner here to see if it helps. So find the unique lines of symmetry. So lines of symmetry is one half is the reflection of the other. Okay, good. Let's take a look at here. The figure shows an equilateral triangle with the center at the origin. Which of the following are magnitudes for rotational symmetry? Now, rotational symmetry means that I'm going to flip it. I'm going to rotate this, and I should finish with the same image. Okay, so let's take a look at here. Let me draw. Let me, I'm gonna draw here on our screen the original picture. And I'm gonna be rotating this. And I'm gonna click all that applied. Oh, do I have 90 degrees rotational symmetry? So if I was to go 90 degrees, no, I don't have it. Um, 270, let's see. There's 180. No, 180 doesn't work. 270 doesn't work. So I'm going from the list on the left. 90, 270, 180 did not work. How about 120? Okay, let's see. What I'm gonna do for 120, let me go 90 first and then 30 more. Ooh, how am I gonna do 30 more? Well, imagine from here to the other side is 90, right? So I'm just gonna go about 30 degrees. Because my symmetry, my rotation changed a little. Okay, 120 did work. 120 did work. Okay, so there's 180. 240, it's about here. My center is moving a little. Oh, 240 does work as well. So I'm just saying, I'm at the degrees, which degrees will actually work. Could be more than one. So when I have this, I'm gonna say 180 and 240 did work. Lastly, the figure shown is a rectangle. Figure shown is a rectangle. How many magnitudes M, where M is between 0 and 360 degrees of rotational symmetry about the centered are there? Okay, so what I'm doing in reality is I'm going to rotate this. And then let me mark, give or take, it's about there. What I'm saying is, if I was to rotate it in the middle, mine might be a little bit off. If I was to rotate it in the middle, if I was to go all the way around, if I was to go all the way around, how many times did my picture is gonna match this red mark right here? So let's see. So I'm gonna start. So far it hasn't matched. It hasn't matched. Remember, I'm gonna go all the way around. How many times does it match? There's one. Like I said, it's off a little because my picture did move a little. So it matched once. Let me keep on rotating. It doesn't all the way around. People might say, "Oh, it matched the second time." Well, the initial and the ending doesn't count. So how many did it match in the way? One time. So my answer for number 32 will be one. Like I say, you rotated this 360 degrees. So you went all the way around. How many times did the image overlap? The rotating image overlap the original image. Okay. Now the rest of the week, we're just going to review for the unit because we have a unit test this Friday.